If you need to solve a polynomial equation, there is a very easy way to do this in MATLAB. We have a function called roots. So let's type the function roots. As you can see, this function takes only one argument, p, which is a vector. And we will talk about vectors shortly. For now, all you need to know is that in order to give it the polynomial you want to solve, you just need to supply all of the coefficients of all of its powers. For example, I have prepared several equations here that we can try. If I want to solve the first equation, this equation, I only need to supply its coefficients. If there is no coefficient, the coefficient is 1. So I need to supply 1, 2, minus 8, and 2. I need to do so inside the brackets. I need to use square brackets like this. So 1, 2, minus 8, and 2. Let's run it, but suppress the output of our previous example first. Let's run it. And these are our 3 roots. We have only 3 roots because the highest power that we have is 3. Let's see the next example. We have 3 times x to the power of 3. We have nothing to the power of 2, plus 4 times x, and minus 2. So the coefficients here are 3, something, 4, minus 2. Whenever a power is missing, we need to give it the coefficient of 0. So let's type this equation, let's try it. 3, 0, 4, minus 2. Let's run it. And we get some complex roots. Again 3 roots because again the highest power that we have is 3. And the final example, we have 5 times x to the power of 6 plus 3 times x to the power of 5. Then we don't have anything for the power of 4, the power of 3, and the power of 1. So our coefficients would be 5, 3, and then we have 2 zeros because we are skipping 2 powers here. 2 zeros, 4, 0, 3. So let's try it. Roots 5, 3, 0, 0, 4, 0, 3. Let's run it and we get 6 complex roots. So this is how you can solve polynomial equations. Let's move on to something different. MATLAB also gives us functionalities to easily obtain the greatest common divisor, for short GCD, and the least common multiple, for short LCM, between a set of numbers. For example, we can use the G. Let's suppress the output from our roots. If we want to get the GCD between 6 and 2, we use the function GCD. Open brackets and supply both numbers separated by a comma. So here we are not using square brackets, at least not yet. Let's run it and find out what is our greatest common divisor, and that is 2. Let's try another example. So GCD, let's say 7 and 2. In this case, our greatest common divisor is 1. You can also test a set of numbers against one single number. So if we have the numbers 2, 4, 6, and 15, and we want to find the greatest common divisor between each of the numbers from our set and 2, we do it like this. We create a set of numbers with square brackets. We write all of our numbers just like we did with the roots, and close the square bracket, comma, and supply our number that we want to test them against. Run it. And for all of these numbers, 2 is a greatest common divisor except for 15, where 15 and 2, their GCD is 1. You can also test 2 sets of numbers, but when you do this, the length of both sets must be identical. So if you want to check a set that has 3 numbers in it, you have to check it against another set that also has 3 numbers in it. So let's try with 5, 6, 7 and 2, 3, 4. Let's run it. And 1, 3, 1. These are our greatest common divisors. 1 is between 5 and 2, 3 is between 6 and 3, and between 7 and 4 we get a 1. And finally, the least common multiple, LCM, It works the exact same way as the GCD. You can test only two numbers, you can test set of numbers. So let's quickly see a few examples. Let's try 9 and 27. Let's run it. The least common multiple is 27. Let's try 3 and 4. The least common multiple should be 12, and it is. Let's try a set of numbers. So 3, 5, 8, 15 against 4. And the least common multiple between 3 and 4 is 12, between 5 and 4 is 20, between 8 and 4 is 8, 15 and 4, 60. And finally, we can test two sets of numbers. So 5, 6, 7. We are going to test the same sets of numbers, so 2, 3, 4. Like this. Let's run it. 10, 6, 28. Now let's document our code. This is polynomials GCD LCM. Roots of polynomials GCD and LCM. So we are adding more and more sections to our file. It's looking pretty good. It's looking pretty good and ordered.